Well, I'm going to start creating the main function using the net package, which is the standard package of Go. And another thing that I would like to mention is that in this video, we are not going to use any extra library or package, but we are going to use only the standard packages in Go. And that makes sense, right? Because when you are building your own protocol, you cannot rely on others to provide you the package or the code for that protocol. You need to understand the basic net package in Go and how you can leverage that to create a proper connection, listen to that connection, and then write your own rules for that protocol. So as you can see in the code, I first created a listener object that will listen to all the incoming connections. I created that using the standard net package and calling the listen method. And I provide two fields that this is going to be a TCP connection and the address that I need to listen to, which is localhost 3000 in this case. I will get back a listener object as well as an error. If it is an error, I have no point in continuing forward, so I can just exit the program. But if it is a proper listener, then I can go ahead and start accepting the connection. So on port 3000, I will be listening to all the connections, and if I get some connection, I will simply accept it, and that will give me a connection object. Now I will pass this connection object to a handle function that I will write next. Well, the handle function takes only one parameter, and that is a net.con object. So the connection that we got inside the main function after calling l.accept is a con object, which is of type net.con, and we are passing that object to a handle function. We can handle the same thing in the same piece of code inside the main function, but it would make our code too messy. So we are writing a separate handler function. And well, this is a general pattern for handling any kind of HTTP or TCP request. So going forward, now when we pass the con object to the handle function, we will now start implementing the function. Inside the function, you can see that I'm writing an infinite for loop. So what we are getting is not a single message, but a stream of messages. Until the connection is closed, we will keep getting different messages from the caller or the client who made this connection. We will instantiate a buffer object, which is of 10 byte. And every time when we get a message, we will simply read that message inside the buffer. So this con.read will block until it reads something. So it will read something in the buffer, and after reading that, we can also encounter an error. And if it is an error, we can simply quit this program for now. But if it is not, and if the message was a proper message, then in that case, we will be printing the message. So fmt.println message read, and we are actually printing the message, which is the string version of the buffer that we read. Also note down that read takes in a slice and not a fixed size array. So we actually use this colon operator, which will simply expand this fixed size array into a slice, and we will be writing everything to that. So we are done with the code, at least the basic code, and now we can go ahead and run the program. So I'll just type in go run main.go, and this will start our server. As you can see that I have not printed anything on the terminal, so that doesn't mean the program is not running, the program is already started. I will just open a new window and use this command nc localhost 3000. So nc I think stand for netcat maybe, but I'm not sure. So what it basically does is that it opens a connection with localhost 3000, and when we write anything down, it just writes the message to the connection. So let's write our first message ABCD. Now if you go back to the server, you can see that a magical thing has happened. It is now printing message read ABCD. So that means the messages that we write here are being successfully read. Let's try to write something else, ABCDEFGH. And as you can see, the same message is being written here. And also note down that the message is now 8 bytes, ABCDEFGH. So now let's try to write something which is greater than 10 bytes. So if I write down ABCDEFGHIJK, which is actually, I think, 11 bytes. So if I write that down and go to the server, I can see that in the first line, I'm reading up till J, which are the first 10 bytes. And in the next line, I'm reading the last message K, the last letter K. which is the 11th byte. So it is not reading everything at once, but it is reading in chunks of 10 bytes each. And this is very important because let's say that you have a large file and you want to transfer that file over a TCP connection. Then instead of passing the whole file at once, you can actually pass it in chunks. And you can note down or keep a note or keep a track of all the chunks that you have read till now. And in the end, when you get all the chunks, you can then combine them together. And this is an example of where we actually might need a protocol. So let's say that we are building our own file transfer protocol. So how do you think we will go ahead with that? We will now divide the file into maybe let's say 10 chunks, and before sending each chunk we will first send a byte that uh, or an integer that this message that the message that is going to be incoming now is going to be let's say 10 bytes in length, or it is going to be 100 bytes in length. So let's say that we have a file and we have like divided it into three chunks of 100 bytes each, 100, and let's say that the file was 210. So the first two chunks would be 100 bytes each, while the third one would be 10 byte. So now the file is divided into 100, 110. So the first message would be 100, the value, the actual value 100, the actual integer 100, and then we will send the first chunk. So when we read the first byte, we will know that 100 bytes are incoming as the first chunk. Similarly, we will do that for the second chunk. We will send the integer 100 first and then the 100 byte chunk. After that, for the third part, we will then send an integer 10 in this case, and then the remaining 10 bytes. And we know that the file now is complete, and we will then send an end of file message, and we will combine all the chunks together. So folks, I think we have a simple server that can actually read any file of any size. How cool is that? So moving forward in the video, you can see that this is the first connection and we are writing all the messages from the first connection. Now I will try to start a second connection here, because we know that when you're running a server, whether it is a TCP chat server or a backend server or anything, it handles multiple connections at once, not just one connection. So now what we will go ahead and do is that I will just start another terminal and we will start another connection, nc localhost 3000. It connected perfectly with the server. There were no error there. But as you can see that if I write a message here, hello world, it doesn't print. Let's try to write something else, some random gibberish message, and you can see that it doesn't print again. Well, what is happening here? Let's go ahead and write the message back in the first connection, SKKK. I'm just writing some random letters here. So you can see that the messages are being printed again. And if I write something else like hello world from connection 1, you can see the message is being printed there, but in parts obviously, because we are reading 10 bytes at a time. So hello world from connection 1 is being printed completely. We are reading that full message. But that is not happening when we try to write from the second server. So why is that? Well, as you can see that we are reading a connection and we are handling that connection. And the loop, the for loop inside the main function, and if you look at line number 22, this loop will not move forward until that connection is broken, or we terminate that connection, or we come out of that handle function. And there is only one way to come out of the handle function, and that is when we get some error while doing a con.read at line number 32. So only in that case we will be exiting this for loop. So let's go ahead and modify this a bit. Now what I will do is I will, instead of doing a log.fatal, instead of exiting the whole program at once, I will simply do log.println. I will just say that we have encountered an error and I will return from this function. So this loop will exit, this function will exit, and let's go ahead and run our program again. So as you can see that if I write something hello world from connection 1, if I write something like ABCDE and DFG, anything random, you can see that I am reading the message on the server side, But at the same time, when I'm exiting the connection, I exited the connection one, and you can see that I'm getting an error that uh, this connection is closing down. So we are exiting this connection, and now I connect with the second one and I write something else. It is being written correctly. So this is connection 2. I'm writing down connection 2, and at the same time, now I will try to connect back with the connection 1. So will this work? I don't think it will, because we are still holding the connection 2. Now what I will do is I will just exit the connection 2. After that, when I write again connection 1 again, you can see that I'm completely reading that message. And not also that, but I think we also read the connection 1 message. So I guess that was in the queue maybe or something. So that message was also read, and we also read the second one. So this gave us quite a bit of insight into the server. But again, we don't want that, because this is not what we want. We want it to handle multiple connections at once. So can you think of something that we can do which will also work in this case? Well, here comes the magical coroutine. Now, whenever we accept a connection, instead of like blocking the whole for loop at line number 22, we will just use a go keyword and handle those connections asynchronously, or I would say handle those connections concurrently at the same time. And this is one of the benefits of using multi-threading or even the go routines, is that instead of like blocking on one particular thing, you handle multiple things concurrently. And in case of network calls where we actually need to wait for something, uh, we can switch between different connections, and as the messages are incoming, we can listen to them and print those messages. Now what I will do is that I would also like to know the IP that is connecting to me. So there is a method on the connection object which is the remote address. So if we just go ahead and print con.remote address, we will know the address that is connecting to us. In this case, they are simply localhost as IP because we are connecting from the same machine, but the port number is randomly generated. So you can see that these are the random port numbers that we are connecting to. Now after doing that implementation, I will go ahead and try to open 3 connections at a time. And you can try doing this, and you can even experiment with this. Clearly, you can see that I am able to write everything from different connections at the same time. And this is the power of coroutine. Since the network call can be blocking, then instead of waiting on just one uh, port number and IP that we are reading from, that we are connecting to, we can now have multiple port numbers / IP combination, and we can connect with them at the same time. By connection, I simply mean that we accept their connection and we wait for them to send messages. And as they keep on sending messages, we read those messages and print them back on the terminal. We can also go ahead and write messages to the connection that we are reading from. So in that case, instead of using con.read for reading the connection, we will be using con.write to write back to the connection. And when we do that, in a way, we complete this whole to and fro communication. So in the future video, we will be writing back to the connection, and we will also go ahead and try to convert this into a proper chat server. So this would be a proper chat server where we would be actually holding all the connections. We would be actually keeping track of all the connections from different clients. And when we get some message from a client, we will be replying them back. So this would be an echo server in the beginning, and later we would actually modify it to be a chat server. If you like this video, then consider subscribing to the channel. As an experienced blockchain developer and a faang engineer, I know the topics required to actually understand core distributed systems. In the future, I will be making more such no-nonsense videos on programming, DevOps, system design, and of course my favorite topic, blockchain. Have a nice day, and I hope to see you back in the next one.